Okay, so I want to go through a couple of. We're still dividing polynomials, but I want to go through 3 examples, kind of outlining a couple of tricky situations. The first situation I want to go through is this one, where we note the different thing here is that we've got an x cubed and x squared, but we don't have an x term. And basically, when we don't have an x term, what we want is we need to have an x term. So we just create one. But since there isn't one, that means how many x's do we have? Well, that means we have 0 x's. So when I actually write this out, I'm going to write 6x plus 3. But when I divide, I'm actually going to divide by 6x cubed plus 3x squared. No x terms. So how many x terms do I have? 0x minus 2. So now I have, to the power of 3, to the power of 2, to the power of 1, to the power of 0. So I have all of them counting down. Once I have this in place, it just helps with the organization, and just kind of keeps everything in check. So anyway, okay, so let's go through this. Now, what do I need to multiply 6 by to get 6? Well, that means a 1, so the coefficient is just going to be 1. But to get an x to an x cubed, I need 2 more x's. So x squared times 6x is 6x cubed. But x squared times 3 is, in fact, 3x squared. So that's good. And note that when I subtract, I don't get any 6x cubed minus 6x cubed goes away. And in fact, 3x squared minus 3x squared also goes away. So I actually have 0 3x squared. Looks like I'm going to have 0x minus 2. So 2 is the only thing I have. Well, that's it. I'm done, actually. Like, I can't actually divide negative 2 by 6x because there's no way to get rid of the x to get to negative 2. So actually, I'm finished. And so, in fact, this is my remainder. So my answer is, in fact, simply x squared plus negative 2 divided by 6x plus 3. So writing my remainder as a fraction, I end up with this. So that was kind of a weird one where all my terms dropped out and I was just left with my constant. And when I'm just left with a constant, that's my remainder. Let's do another one. Kind of the same idea. So here I'm going to have 3x plus 9. And I am going to divide 3x to the 4th plus 9x cubed. There's no x squared, so I write plus 0x squared. Then I write plus 21x plus 55. Okay, so going through our motions here, we got 3x to 3x to the 4th means the 3's there. All I need is 3 more x's, and I get 3x to the 4th. X cubed times 9 is in fact 9x cubed. So the same thing happens here. So when I subtract this, this goes away. The 0, that's just 0. So in reality, I just have 21x plus 55 here. And then I can say, okay, well, what else do I need? Looks like I need from a 3x to a 21x. Looks like I'm going to need a 7. 7 times 3 is 21x. 7 times 9 is 63. And so when I subtract that, I'm getting 55 minus 63, which, by the way, is negative 8. And that's my remainder. So my answer here is going to be x cubed plus 7 plus a negative 8 over 3x plus 9. There we go. Let's do another one. This one is a little different because it doesn't have anything missing. So I'm not, notice x to the 4th, x cubed, x squared, x, and then constant. So it has no terms missing. The different thing here is that I'm actually going to divide by a trinomial. So when I do that, setup is exactly the same. X squared plus 2x minus 1, just like that. And I am dividing my x to the fourth minus 2x cubed, my bad, plus 3x squared minus 4x plus 6. All right, so to get an x squared to an x fourth, well, I have two x's. To get up to 4 of them, I need 2 more. So that's going to be x squared, right? X squared times x squared is x to the fourth. But now I'm going to have 3 terms down here to subtract, not just my normal 2, right? So 3 terms. So x squared times 2x gives me my positive 2x cubed. And my x squared times negative 1 gives me my negative x squared. Now remember, I'm subtracting. So x to the fourth minus x to the fourth goes away. Now this one's a little tricky, and the reason it is because as you see a 2 and a 2. And so oftentimes people just say, oh, my 2's cancel, done, move on. But that's actually not correct in this case because it's negative 2 minus 2. So this is actually negative 4x cubed. So be careful with your negatives again. 3 minus negative means that I'm adding, so 3x squared plus an x squared gives me a 4x squared, and that's going to be positive. Then a minus 4x plus 6, just bringing everything down. If I need to go from an x squared to an x cubed, I'm going to need an x, and I also need, well, 1 to negative 4, so I'm going to actually have to multiply this by a negative 4x. So negative 4x gives me my negative 4x cubed. Negative 4x times positive 2 is going to be negative 8x squared. And negative 4 times negative 1 is going to be a positive 4x. Again, be careful, we're subtracting. Okay, negative 4 minus negative 4, that's negative 4 plus 4, so that goes away. This is a positive 4 minus negative. Minus negative means I'm adding, so 4 plus 8 is 12x squared. Negative 4 minus 4 is a negative 8x, and then we bring down the 6. All right, last thing. So to get to x squared, to get to 12x squared, I need a 12. So I'm going to put plus 12. This will give me a 12x squared, but it's also going to give me a plus 24x and a minus 12. Now, note, so now I'm subtracting. That goes away. Negative 8 minus 24. Negative 8 minus 24 is in fact, let's see, well, if I have a negative 8 and I'm subtracting 24, that's actually going to be, let's see, 32, oh, negative 32x, right? Negative 8 minus, so that's negative 32. 6 minus negative, that means I'm actually adding. So this is actually going to be plus 18. Now, notice, since my leading term here is an x squared, I can't possibly make an x because that would be going down a degree. Once this happens, that means I'm finished, leaving me with this guy as my remainder. So my actual answer here is going to be x squared minus 4x plus 12 plus negative 32x plus 18 all over what I was dividing by, which is an x squared plus 2x minus 1. And that's your final answer. So that is a super ugly one. In almost, I will pretty much never be giving you anything quite this ugly, but it's good to see, just to, see that we can overcome all these little hurdles pretty easily just by kind of sticking with the method and going through in a very logical manner. So, but yeah, you probably won't have anything quite this ugly, but here it is. So hope you enjoyed that, and good luck with the rest of the homework. This should get you through homework 4 as well. And then you can do, on Friday, we are going to do the test review. So you can get started on that, and then we'll have a test on Monday. So anyway, good luck, and I will talk to you later.